Hey y'all, want to talk about the Graphical Random Walker and the PixelWalker. Hopefully you're done with the Graphical Random Walker. We'll go ahead and call that up real quickly here and make sure that we're good with that. I'm going to be using Command Tab to switch from document to document today, or from application to application. So here I am in Safari. If I hit Command Tab, I get a bunch of other options, things I can switch to. And I'm going to switch to BlueJ here so we can see there's my Graphical Random Walker. If I hit Command Tab again, it switches back to where I was before. So it's super easy to switch from app to app. That's Command, hold down the Command key, and then Tab, and that'll get you there. That would be the Alt key on your PC laptop if you're working on that. So here's my Graphical Random Walker. Let's just double check and make sure it works. It's compiling. I'll do that Command backtick to get over to another window here and compile and run that. And yeah, it looks like it's working great. I'm printing stuff out. So this is a Graphical Random Walker because we're using a graphical interface. We can visually see what's going on. But we want to, instead of using text, we want to be able to use pixels. So I'm going to switch back over here and this. For the pixeled version, I'm still going to be using the same walker, so I'm going to go ahead and grab all this text here and copy that. And I'm going to go ahead and quit BlueJ then and open up processing so that I can figure out what's going on here. So processing app, open that up. And what I'm looking for here, the assignment is down here in graphics. PixelWalker right there. I'm going to open that up because that has all our instructions that we're going to be using to write this. Hopefully we can knock this out pretty quickly and see if we can get this working. So remember, I've got the Walker class saved. Let me take a look at this using the processing platform. Write a sketch PixelWalker. Here's the Walker class. We've already done that, so we're good with that. The PixelWalker class. The main program must be the first leftmost tab in the project. So let me go to processing here. Here I am. This is the leftmost tab. I'm going to call it PixelWalker. So maybe I'll just go up here to save. Call it PixelWalker. I think I'm just going to save that on my desktop here. So that's where that project will be. And once we've saved that project, click on the down arrow in the tab to create a new tab for additional classes, in this case Walker, that should be included in the project. Okay, so I'm going to do that. There's the down tab. I'll click on that, and there we go, new tab. And this is going to be the Walker class. Okay, I'm going to expand this a little bit so we can have more room to see what's going on. And I'll just paste in that Walker class that I had from before. It says it might be missing a name or something down here, so I'm going to jump up here and see. One of the things that turns out processing doesn't like is these Java docs up here, so I'm going to get rid of those. And then here I've got an open curly brace, and maybe I didn't quite copy that closed curly brace down here, so I'm going to put that in there and see if it likes that. Looks like it likes that. Okay, so there's my Walker class. Pretty good. It doesn't like that, the illegal modifier for the local class. I'm going to leave that in there. We'll see if it works. If that doesn't work, I may come back and take a look at this. One of the things I'm thinking about is the fact that everything is public in processing, so it may not like the word public there. So we'll get rid of that. Oh, and it looks like the error went away. It still doesn't really like this here, but that's okay. We'll see if that works for us. And then PixelWalker, this is going to be our main program. Just as in BlueJ, we had the Walker class and then the Graphical Random Walker main program that ran that. In processing, we're going to write this main program, which includes these three items: instance variables declared, a void setup, and a void draw. All right, let me run over and do that real quickly. So declare instance variables, just writing a little note to myself. And I'll do void setup, because we always have to have one of those, curly braces, and then void draw. You don't always have to have a void setup, and you don't always have to have a void draw, but if you're going to use the listeners, and if you're going to have this thing repeat over and over, it's kind of fun to be able to set it up this way. Also, print in the console the coordinates of the walker and the number of steps it has taken. Okay. Oh, that's in addition to all of this stuff here. So the draw loop's going to repeat itself, and it says something about the pixels being very small. See extension 1, I think they actually mean extension 0 down there. So let me go in and start doing all this. What instance variables do I need to keep track of as I'm working through this? I'm going to Command Tab, again, to switch my back and forth between Safari and this, kind of useful. So what do I need to keep track of? I think I need to keep track of the X and Y position. So I'll declare instance variables there. I need to have a walker. I'm going to have a random walker that I'll call W. I'm going to have a step counter. So I'll keep track of the steps there. I think that might be it, although there'll be something that we'll add in there a little bit later on. I think that's it for right now. Now in the void setup, this is like almost a constructor here. We need to make sure that we initialize all these. Declaring is just saying we're going to have these variables, and then we need to initialize them. So the X coordinate is going to start out at 0. The Y coordinate is going to start out at 0. I'm going to make a random walker. My W is going to be a new walker. It starts out in the middle of the screen, and I haven't really set that up yet, so I'll do that in just a moment. And then I'll set steps equal to 0. There I've initialized my variables there. But yeah, a couple things. I want to put the walker in the middle of the screen, but that depends on how big the screen is, and we determine the size of the screen by saying size and then giving it a width and a height. I'm going to do that right there. 800 across by 400 up and down. And that allows me to do things like if I want to put the walker in the middle of the screen, I'll put the walker at width divided by 2 and height divided by 2. Put the walker at that location, and then we'll see the walker. I think real quickly, I'm just going to double check and see what's going on. Maybe I'll just go down here. Yeah, right after this, I'm going to print line W. Now, because in our walker, because we have a toString method that's set up, if we try to print an object, it's going to print out what's going on there. So this is going to run through the initialization, the setup, and then it'll start the draw loop. And I'm not doing anything in the draw loop. I just want to see what's happening here, first of all. So if I run this, it made the screen for me. That's kind of cool. And it made a walker at 400 and 200, which is in the middle of the screen. So that's awesome. Not a big fan of this gray, so that reminds me I'm going to do the background as 0. That'll be black. So when I run it now, I'm going to go ahead and end up getting a black background instead. That's cool. I like that. And then let's do this before we get into drawing the walker on the screen. Let's just watch the walker move around. Let's go ahead and say we'll print line W. I'm going to go ahead and put that in the loop as well, maybe. Maybe I'll move the walker. Yeah, W, move. That'll move it in a random direction. And then I'm going to print line walker. Now, if you just print, it just prints it down out here in the console, and that doesn't help us with our screen here. But this is a nice way of watching what's going on. Maybe I'll even model this too. In addition to printing W, I'm also going to print space steps taken equals, and then I'll print out the number of steps it's taken. And every time I move the walker, I'm going to add one to the steps. So this loop, which repeats over and over and over, is going to move the walker, increment the number of steps, and then print out that situation. And what happens when I run that? Is it working? I'm not seeing anything in the screen there, but I am seeing the walker here. Steps taking, it's updating that. And I'm wandering around on the screen, even though I can't actually see it yet. So it looks like the basics of my random walker are working just fine. This is a nice little demonstration that, at least in principle, everything's happening the way it should be. Okay. Well, how have I done here? I've set up I've initialized instance variables and set up a graphical window. Good. I've set up a loop that displays the walker and its position Well, I certainly did that, but it's not the graphical one. We really want to do, I guess this is what I've set up here. I also want to be able to graphically present the walker here. So let's figure out how you do that. Go back over here. And in addition to printing this out, let's go ahead and put that walker on the screen. So the screen is 800 by 400. The walker is at 400, 200. So I'm just going to make a little circle there, I think. A little circle. I'll make a circle. At position W get X, that's where the walker is. And at position Y, that's where the walker is vertically. And how big am I going to make that circle? I'll just make it 1. If I make it with a diameter of 1, let's see what happens when I run that. Let's see if I'll be able to see that on the screen. So here we are running. I know we're wandering around, and here's my window. Can you see the random walker there moving around? I'm going to zoom in here and see if I can see the walker in the middle there. I'm pretty much zoomed in as much as I can be, and it's really hard. I don't see the walker there. Pixels are so small on here. Maybe I'll, not sure if that's working or not, so maybe I'll make the diameter 5. That'll give me a better chance to see where the walker is there. If I run that now, oh, there it is. There, I can see it now. It's still a pretty tiny little circle, and it's moving very fast, but it's kind of jumping around. And notice it's leaving little artifacts. We saw this in class. It's leaving little artifacts, which has to do with the stroke around it, the line that runs around that circle. So let's start thinking about fixing this up a little bit. First of all, in our setup here, we'll say no stroke with a capital S. And let's set the fill equal to something interesting. We'll set the fill equal to maybe red. We'll do all red, no green, and no blue. And we'll see what that looks like when we run that. Oh, well, it's not leaving any artifacts around now, which is kind of cool. But it is kind of leaving a blob there. So I think what I want to do is, since I want to see the walker moving around, I want to go ahead and stop that for a second. I'm going to clear the screen every time the walker moves. So I'll reset the background to 0. That'll wipe out whatever was there before, every time right before I do the circle. So I'll put that in here. So I'm going to move, update the steps, print out where I am in the console, and this is the graphics part. Clear the screen, and then print the circle. And let's see what that looks like. So now we're back to that thing kind of jumping around, and it's not leaving any artifacts there. So that's pretty good. I'd like to know about how close I am to the center. So it would be nice if we could put the center in there in a different color. And so maybe I'll make it blue or something. So every time after we clear the screen, let's print out where let's put a circle in the middle as well. Circle is going to be located at this position, width divided by 2, height divided by 2. I'll just copy that. I'm going to make a circle at that location with the same diameter 5, but I want to make it a different color so it doesn't get mixed up with the walker itself. So I'm going to reset the fill to 0 red, all green, and no blue. Sure, that'll work. And then I'll set it back to red so that I can print the walker. So it always prints the circle, displays the circle with whatever the last fill was here. So when I set the fill to red, I'm in red mode. When I set the fill to green, I'm in green mode, and this just hops back and forth between those two. So now when I run it, it looks like I've got exactly what I'm looking for. The green is in the center, and then the red is the dot that's kind of hopping around there and maybe getting close to it, maybe not. So I really just have one other little thing, a challenge that I want to add in there. This is pretty good. This is working the way I want it to do. There's some details like the wrapping. We might want to do the wrapping where, you know, when it wanders off one side, it comes back on the other. That would be a good thing to be able to do. Maybe I'll do that in just a moment. Here's the challenge. It's so small there. And even though we've made this circle with a diameter of 5, like if I make it with a diameter of 10 to see what's going on, the walker is only moving 1 every time. So when I run this now, even though I've got this huge circle, it's just kind of shaking around, jiggling around a little bit, a huge circle, but it's only moving 1 tiny little step at a time. And it's doable, I guess, but it seems to me that if this is the smallest circle I want to use, then I should be moving by that smallest amount. I should be taking a step that's equal to the size of the circle. And so the way I'm going to handle that is by using something called scale. And if I go back over to the problem statement over here, they talk about the fact that we're going to be using a constant scale. For a walker with small dimensions, or that's changing its location by only 1 pixel each move, the movement of the walker may be difficult to see. Include a constant scale in the program that allows the walker's motion to be reasonably displayed on the screen. And let's take a look and see what this means. If you were in class, you may have picked this up the first time, but if not, take a look here. So this is our screen. This is our computer screen. Can I take a look at that and see what's going on there? No. Oh, excuse me for a moment. Yeah. Is that what I'm looking for? There we go. So this is the computer screen with all these pixels going across. You have thousands of pixels going across. In this one, there's just 16. So we might be able to see a pixel if it was this large. But with thousands, we're not going to be able to see an individual pixel. So what we want to be able to do is we want to have a scale of 4 where we say these many pixels, pretend that we have 4 pixels across and 4 pixels down. These many pixels represents 1 pixel or 1 location for our walker object. This is the computer model over here, as opposed to what's being printed on the screen. So what that means is if I think the walker is here and the walker does +1, x +1, it's going to move over to this position. And that means I need to not just move +1 on the screen, but move +4. I have to move over 4 positions, or whatever scale is. Or if I'm moving down, I have to move down 4 positions to get to that next location. Those locations correspond. These locations correspond. So I'm going to have to make some adjustments. And they're pretty easy to do, but it's easy to kind of confuse them a little bit as you're working. So let's take a look and see how we might do that, keeping in mind that scale there. So first of all, get back over there. So first of all, where is the walker going to be? The walker is always going to be in the middle of the screen. But I guess the representation needs to be a little bit different. In other words, if I've got a screen that's 800 divided by 2, that puts the walker in the middle at 400. You can see it's down here at 400. But I can't see all the 400s. I'm going to set up a scale value here. I'm going to say int scale. And I'm going to set up a scale value here that will help me calculate where the walker is in the model. I'm going to say scale equals, let's say 10. So back to the middle of the screen here. The middle of the screen is 800 divided by 2, which is 400. But I need to scale it down because the walker doesn't have 400 going across. The walker is only going to have 40 because of the scale, 40 going across. So I need to take this middle position and divide it again by the amount of scale. And this height here, I'm going to divide it again by the amount of the scale. So what happens when we run that? I want to run that real quickly and then just stop it. You can see down here the walker is no longer at 400, 200. Now it's at 45, 29. That's a larger location. That's this reduced in, what is this? I guess this is, I guess it's a granularity. It's got this reduced granularity, this reduced scale here. So again, rather than 400, I'm going to be looking at 40, and it looks like this is doing that down here. But you saw when I ran this, what was going on. This showed up in the middle again, which is cool, but the walker up here, oh, well, I guess this is 40 and 20 on the screen. It's 40 and 20 in the walker's model, but I don't want to print out 40 and 20 on the screen. I want the 40 and 20 to be printed out over here in the middle. So how do I do that? I guess when I'm printing, when I'm printing the walker, here's the middle right here that I'm always doing in green. When I'm printing this walker, when I'm getting the X, I need to take the walker's value and multiply it times scale. If before I was setting the walker up at a position divided by scale, now I'm going to multiply it by scale. So it'll show up at the location on the screen, the correct location, using that circle there. And maybe I'll even set 10 equal to the scale. If scale is 10, then I'll be doing 10s here. So this will adjust if I decide to adjust the scale a little bit later on. Okay, well, let's see how that works. Oh, that's kind of cool. So it looks like it's going very, very fast, but it looks like it's wandering around and it's jumping. It's either going up or down or left or right, just as a regular PixelWalker or a random walker would do. So this seems to be working just exactly the way, just exactly the way I want, except it's wandering off the screen. So we're going to have to fix that. We want to be able to wrap around. That's another thing that we have to do. So let's stop this and we'll go back and fix that. But it looks like that's the right part, right? It looks like we're doing kind of the right thing there. So how did we keep it from wandering off the screen? I guess every time we took a move, right before we did all the other stuff, we checked that move to see if the walker needed to be moved to the other side of the screen. So if the walker wanders off the left side of the screen, that's going to be 0. So we'll check and see. If w.getX is less than 0, that would be wandering off the left side of the screen, then what are we going to do? We are going to set the walker's position to a new value. And in the bad old days before, we would set it to the width minus 1. But the width minus 1, that doesn't really work anymore because, again, the walker has a smaller space here. It's factored down by scale here. And width is going to be that 800 value. So I don't want the 800 value there. I want it to be width divided by 10 or divided by scale. That means it'll set it back over to that 80 position. And then we should be able to do that. Width divided by scale minus 1. There we go. Will that work? Oh, no, sorry, I don't have an extra parenthesis. Sorry. So we'll set that X to the new value there. That'll put it over on the other side of the screen. I think that's going to work, but I'm going to double check that a little bit later on. What if w.getX gets to be equal to, greater than or equal to, the width divided by scale? What happens if we get to that right side of the screen? The 800 pixels divided by 10, that's going to be 80. If the walker gets to position 80, I need to reset it back to 0. So I'm going to do that. I'll w set x back to 0. And maybe I can space this out a little bit. You know, I like to space these out so I can see all the different things that we're going to be doing here. Make sure that we're following the patterns okay. Let's do the same thing with y. What happens if w.getY gets to be less than 0? What am I going to do? I'm going to set y equal to the height divided by scale minus 1. That'll wrap it around to the other side. And if w.getY is greater than or equal to the height divided by the scale, if it goes to the bottom of the screen, then I'm going to reset y to the top. And we'll see what happens there. Yeah, I think that might do it for our wrapping. Well, let's test it and see what happens. Oh, it doesn't like something. Can you see what I did wrong here? Oh, I forgot to close the... There we go. Let's run it and see. Oh, there it goes. It's running around. And I'm waiting for it to go off to one side or another to see if it wraps around the other side. There's one more thing I think that would be interesting to do. We'll see if this works first. Oh, wrapped around on the other side. That was kind of cool. Awesome. So I'm hoping it's going to also work top to bottom. Looks pretty good so far. Let's do one more thing. What happens if we don't clear the screen every time we draw a new circle? What happens if we don't reset the background to 0? Because that clears the screen. If we don't clear the screen, what does it look like when we run the PixelWalker? Nice. So now we get to see a little trail here of where the walker's going. Oh, it looks like it went right over that anchor. I'm not stopping this when it gets to the anchor. We have to implement that at some point if we wish. We can also find a way to print out these positions and steps on the screen so everything is nicely presented there. That's kind of cool. Well, now that the basic principle is working, let's play around with it a little bit more. I'll change the size. I'll make it a slightly bigger screen this way, maybe 700. And let's set the scale up to, I don't know, something crazy like 60. What does that look like? Nice. So everything's adjusting automatically. The size of the, when it wraps around is adjusting automatically. Oh, it looks like I might be off by 1 here. It looks like the when I get to that width there, that rounding down might be an issue. I'm also looking to see that the green there doesn't match up with this right here. So what's going on there? That's a bug that I need to figure out because ideally, those things should be lined up. This position right here would be right there at the middle. Oh, doesn't it? Oh, it looks like the center of this runs through the center of that. I wonder if this is a question of where we're actually drawing the middle there. Yeah, when we draw that middle, oh, the middle there. When I draw that middle, is that in the wrong place? I mean, it's approximately in the right place, but it looks like if I may be off by a little bit, I'm going to have to think about that. That'll be something for me to debug. Really interesting work here. All right, I'm going to fix that. How do I fix that? I have an idea. What happens if I take this width, divide that by scale, then divide by 2, and then multiply by scale? I know those are inverse operations, but I'm wondering if this dividing by 2 is giving me an int that I somehow am not dealing with. Maybe there's those are inverse operations, but I'm going to do the dividing 2 after I've scaled that down. Will that set me up in the right place? That does. That's a tricky little adjustment there. So the green is actually now in the middle there where it belongs. And again, I've got this little -1 over here. I think that's an off by 1 error. That's a little bit tricky. If I change this here, we'll be moving it, because this ends up rounding down when we do that division. So what happens when I run that now? It was working just fine over here, but as we get over to the edge, I want to see if we end up going past that at all. And there's one there. I'm going to get a little farther over. Let me try again, do another run. If I really wanted to see where it printed out there quickly, I would. Yeah, it's pretty good. I'm not sure it's printing out at that last little space there. Yeah, it may be that there's an issue there with printing that out. Okay, well, I'm gonna leave it at that for right now. I think it's pretty good. Maybe I'll change it one more time and take a look and see what's going on. What happens if I make this back down to a more reasonable? What if I made this like 23 and ran that? That would be a funky little number there. So we can watch this. This will be how we end the video. I hope this was helpful to you if you are getting stuck anywhere along the way. So many interesting things, and there's a couple more activities that you can do here if you take a look on the page. Using separate colors to identify the walker's origin. We've already done that. Printing the walker's number of steps. You could do some other really interesting things with colors on this, so play around with it and see what you can come up with. And yeah, I look forward to seeing what you can do. Oh, it's so fun. Talk to you later.